Alright, so these are going to be notes on section 3.5, equation solving and modeling. So the first thing that you need to write down, and this is a property of exponential functions and also log functions that helps us solve equations, it's that they're one-to-one. Remember, that means that they pass the horizontal line test and the vertical line test. So we do know that they are always one-to-one. And because they're one-to-one, this is true. So, and we kind of already used this a little bit as well. If b to the u equals b to the v, then u must equal v. Similarly, if log base b of u equals log base b of v, then u must also equal v. So our first example is going to be, we're solving equations, remember. So our first example is going to be to solve an equation. In this equation, a question on a test or a quiz might say, solve this. 20 times 1/2 to the x divided by 3 is equal to 5. So we're trying to solve this equation. Well, the first thing we want to do, again, we're solving for x. It's up here in the exponent, so we need to get that x by itself first. The first thing we're going to do is divide everything by 20. So if I divide everything by 20, I'm going to be left with 1/2 to the x over 3 equals 1/4. Now, in order to use that one-to-one property, I'm going to have to rewrite 1/4. So this is going to stay the same. And I'm going to rewrite 1/4 as 1/2 squared. Because we know that 1/4 is the same as 1/2 squared, or 1/2 times 1/2. So now I can use that one-to-one property, saying that if my bases are the same, the exponents must be the same. So if my bases are the same, my exponents must be the same, then that means that x divided by 3 is equal to 2, setting my exponents equal to each other. So then that means that x has to be equal to 6, multiplying both sides by 3. So this would be your final answer. X is equal to 6. And you could check that answer by substituting it back into your equation in the beginning. Yes? Okay, in the next example, it's going to say solve this long equation. E to the x minus e to the negative x divided by 2 is equal to 5. Well, we never like fractions, so we always want to get rid of the fraction. So the first thing we're going to do is multiply both sides by 2. That means that I'm going to get e to the x minus e to the negative x equals 10. Well, I can't really do too much with this right now, so I want to try and get rid of something so I can make it look like a quadratic function. And how I do that is to multiply by e to the x. So I'm going to multiply everything by e to the x, multiplying the entire equation by e to the x. So that's going to give me e to the x times e to the x is e to the 2x minus e to the negative x times e to the x is going to be e to the 0x. And that's going to be equal to 10 e to the x. Right away we know that anything to the 0 power is always equal to just 1. So now I can rewrite my equation as e to the 2x minus 1 is equal to 10 e to the x. Now I want to make this look like a quadratic function. So I'm going to subtract 10 e to the x from both sides. Now I get e to the 2x minus 10 e to the x minus 1 equals 0, because there's nothing left on this side. Now this pretty much looks like a quadratic function, right? I'm going to rewrite it one more time and maybe you'll see it. If you don't already, maybe you'll see it now. E to the x squared minus 10 e to the x, oops, minus 1 equals 0. So now, how do we solve quadratic equations? We use the quadratic formula. So I'm just going to pretend for a minute. I'm going to set e to the x equal to w. And again, if you don't see the quadratic equation yet, maybe you'll see it now. So I'm going to substitute, wherever I see e to the x, I'm going to substitute a w. So I have w squared minus 10w minus 1 equals 0. Now I'm going to use the quadratic formula to solve this equation. Opposite of b plus or minus the square root of b squared minus 4ac over 2a. So the opposite of b, 10, plus or minus square root b squared. So negative 10 squared is 100, minus 4 times a is 1 times c is negative 1 divided by 2a. Since a is 1, I'm just going to write 2. And that's going to be the same as 10 plus or minus square root of 100 plus 4, so 104 divided by 2, which is the same as 10 plus or minus 2 root 26 divided by 2, which is the same as 5 plus or minus the square root of 26. So, if you remember, we said that w was equal to e to the x. So that means that this is equal to w, which is also equal to e to the x. And since we know that e to the x is never going to be negative, it can never be a negative value, that means we can reject one of these. And the one that's going to be negative is if I subtract 5 minus the square root of 26, because the square root of 26 is a little more than 5, so it'll make that negative. So actually, my only answer is going to be 5 plus the square root of 26. Oops. So now I have e to the x equals 5 plus square root 26. How do I solve for x now? I have to take the natural log of both sides, because anytime I have a base e and it's raised to an exponent that has an x in it, normally they will, in order to be an exponential function it has to, I'm going to take the natural log of both sides. So ln of this whole thing. And the natural log, remember, always has a base e. So the natural log base e of e to the x is just x. So x is equal to the natural log of 5 plus the square root of 26. The entire thing. So you want to do 5 plus the square root of 26 and then take the natural log of that. So that means that x, you can use your calculator for that, x is approximately equal to 2.31. In this next example, we're going to use logs to help us solve this problem. So again, it's going to say something like solve log x squared equals 2. Well, since we know that 2 is the same as log 10 squared, how do we know that? Why do we know that this is true? Well, remember when I just write log times something, that just means there's always a base of 10. If I don't write a base, we assume it's 10. And log base 10 of 10 is always equal to whatever that exponent is. So log base 10 of 10 squared is going to be equal to 2. So now all I'm going to do is take this and replace it in here. I'm going to replace the 2 with it since we know it's equal to 2. So now I have log x squared, that's the beginning of our problem, is equal to log 10 squared. And I had that one-to-one property that said if I have the log on both sides with the same little base, right? Remember, it's 10 here and 10 here. I can set these two values equal to each other. So that means that x squared is going to be equal to 10 squared. So that means that x squared is really equal to 100. And now I can take the square root of both sides, and I get x is equal to plus or minus 10. And that's how you solve that problem. Pretty easy. And I have one more problem to solve like this, and then we're going to do some modeling problems. So the last one, you're going to use your calculator for this one. The last one is going to say solve ln of 3x minus 2 plus ln of x minus 1 equals 2 times ln of x. So there's an x in all three of our terms. So the easiest way to solve this problem is going to be to graph it. But we need to make one side equal to 0. Just as if we were using a quadratic function and we're going to find the zeros, we need one side to equal 0. So all I'm going to do is subtract 2 ln of x from both sides. Subtract 2 ln of x from both sides. I'm going to get ln of 3x minus 2 plus ln of x minus 1 minus 2 ln of x equals 0. Now, you're going to take this right here and substitute it into your calculator and figure out where it equals 0. Well, where does it equal 0? It's going to equal 0 where it crosses the x-axis, right? That's where y is equal to 0. So, your graph is going to look something like this. When you graph it on your calculator, you'll see that it looks something like this. And again, the 0, or where it crosses the x-axis, is at 2, 0. So that means that the only solution to this problem is x equals 2. Again, pretty easy if you have your calculator to help you. The last thing we're going to talk about is compound interest. So that's solving problems using logs and natural logs. Compound interest can be found two ways. So we're going to talk about if it's compounded annually and if it's compounded k times per year. So if it's compounded annually, the formula is always going to be a is equal to p times 1 plus r to the n. And you probably have seen this formula before. This time we're going to be able to solve it using natural logs and logs. In this formula, a stands for the final amount, or the amount after you've compounded. P is the principal, or the amount that you invest. We always have the 1 plus. Our r is going to be the rate, and the rate is always in terms of a decimal, never a percentage. And then in this case, n is going to be the number of years. So our first problem is going to say, let's say I have $500 and I'm investing it at 7% interest annually. Find the value after 10 years. So that means that our principal is equal to $500. Our rate was 7%, but as a decimal, that's 0.07, remember. And I want to find what happens after 10 years. So that means n is going to be equal to 10. I'm going to have a is equal to 500 times 1 plus 0.07 to the n, which is 10. And that's the same as 500 times 1.07 to the 10. And if you do that on your calculator, you get approximately $983.58. Pretty easy. Didn't have to use logs, didn't have to use natural logs. We are going to have to for this next one. So this is if it's compounded k times per year. So sometimes you'll get a question that says that it's compounded quarterly. That means it's compounded 4 times per year. If it's compounded monthly, that means it's compounded 12 times per year. If it's compounded weekly, it's compounded 52 times per year. So you kind of get the idea. K is always the number of times that it's compounded. And our formula this time is going to be A is equal to the principal times 1 plus the rate, again in a decimal form, over K, the number of times per year, raised to the K, number of times per year, times the number of years. So in this case, we're going to use T as the number of years. So our first question is, I'll go to a new page for this. If I invest $500 at 9% interest rate compounded monthly, how long will it take me to make $3,000? So let's write down all of what we know. We know that our principal, I'm starting with $500. I'm investing $500. I'm investing it at a 9% interest rate, so 0.09. It's compounded monthly, so that means our K value is 12, compounded 12 times per year, monthly. And I want to know how long will it take me to have an ending value, so our A value, of $3,000. So again, same thing, just substitute everything into the equation. A, or $3,000, is equal to 500 times 1 plus 0.09, the rate, divided by K, the number of times per year, times, or raised to the K, number of times per year, times the number of years. So what are we doing? We're solving for t. It's in the exponent, so now we're going to have to use natural logs. They're going to help us out here. But we need to get that by itself first. So the first thing we can do is divide both sides by 500. And if I divide both sides by 500, I get 6 is equal to, and I'm going to do all of this on my calculator in one step. It's actually equal to 1.0075 to the 12t. Now I can take the natural log of both sides. And if I take the natural log of both sides, I'm just going to write it in both here. I can use my power rule on the right-hand side to get rid of this exponent. So I'm really going to have the natural log of 6 is equal to 12t times the natural log of 1.0075. Now, in order to solve for t, I can just divide both sides by 12 times the natural log of 1.0075, and I'll get an answer for t. T is equal to ln of 6 divided by 12 times ln of 1.0075. That's a 0. Which is approximately equal to 19.983 blah 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 blah. So that's approximately 20 years. So what does that mean? It means that if I invest $500 at a 9% interest rate, compounded monthly, it will take me 20 years to turn that $500 into $3,000. And in class we will be doing some problems that are very similar to that, using what we know and modeling equations of real life problems.